So this is an unbranched compound. Now, a simple way to remember what an unbranched compound is if I move in a straight line to represent those carbons, for example, I do this, right? If I go in a straight line to represent those carbons, I find that if I go through all the carbons without repeating drawing over the line, then that is an unbranched compound. So let's see, I'm going to give you an example over here, and I'm going to take a thin pen rather than, a little bit thicker than the one I was using, and let's get some red going there. This here is an unbranched compound. In fact, it's right, and I suggest you also practice drawing out all these molecules the way you see them, with all the H's, all the dashes, all the little covalent bonds represented. Now, if we look at this molecule, let's just get a blue pen over there. If you were to draw a line that goes in this direction, and so, you need to ask yourself, do I cover all of the carbon atoms? So are all the carbon atoms, all carbons covered? What do I mean by covered? Are they all linked? And the answer is yes. And in that case, that's an unbranched compound, right? There's no branches. Therefore, there is no branches. So let's look at another one. What if I take this one here, and I'm actually going to just get a whiteboard up. Sorry, my bad. Let's get that up. Let's look at one. For example, let's take this compound. There I've got a compound, I'm going, and yeah, I've got something like so, and I've got something like so. Let's look at this compound. Let's look at the one that you see here, and I suggest you draw it out as well, just so that you get used to drawing out these carbon-based compounds for your examinations. And what I've included here are all just hydrogens. Now don't stress too much about the hydrogens just yet. Just know that we are dealing with the main chain being the carbons. All these hydrogens are on the side. Right. Right. Last one looks a bit rough. There we go. Now, if we were to look at how can I track all the carbons, do I see them here? Let's see if I can trace them. I'm going to track them. I'm going to use a thin pen quickly, and if I track them across, that goes 1, 2, 3, 4, 5, 6, 7, 8. Now, is there a way, we need to ask ourselves, is there a way that I can get hold of this carbon over here without having to go back on that line? And the answer is no. So therefore, this here is the branch in our branched compound. Okay, that is the branch. And what we are seeing above is actually a branched compound. Okay. Now, when you're looking at branched compounds, I will elaborate in a moment. You need to find something which we call the main chain. The main chain, which you can also call the base, we can call it the main chain, is really just the longest chain. It doesn't matter what direction you move in, as long as you don't trace back over that line and you get in as many carbon atoms as possible. Okay, so it's the longest chain. Many people think that it's just meant to go straight. It doesn't need to go straight. Okay. Right, so let's look at another one. Let's look at one, let's keep it on red. Let's say the following. If I have this, and let's draw all that H's. Come on, let's put it in. Let's go. Let's put it in over there. Okay. Now, let's see. We need to decide what exactly is the longest chain. And let's see. let's take blue. If I'm going to find the longest chain, if I go in this direction, I go 1, 2, 3, 4, 5, 6. Is that the longest chain? Well, we got to think about it. Well, that's 6 across. But what if I do this? 1, 2, 3, 4. Is that the longest chain? No, definitely not, because I had 6 across here. If I go there 4, sorry, both of those give me 5. That's definitely not the longest chain. So this one's fairly simple. The main chain is the one in the middle that you see over here. What if I had to change the question a little bit and I do this? Let's see, if I do this, what happens now? What happens now? Okay, let's see. Let's get that blue. If I go 1, 2, 3, 4, 5, 6, that's not the longest chain. 1, 2, 3, 4, 5. That's definitely not the longest chain. What about this one? 1, 2, 3, 4, 5, 6, 7. That's the longest chain that runs like that. Okay, so I'm using a different color just to show you. So what we do is we find the longest chain, and whatever is left, like this over here, that's left, and so is this. Oops, there we go, so is that. These are the branches. That's a branch, and so is this. That's a branch. So you've seen two examples now of what a compound looks like that is branched and also unbranched, right? So we will call this a branched compound. Righto. Let's move on to the next slide. Okay, so that's an unbranched compound. An unbranched compound is one in which you can see if I move like so and I cover all the carbons, I don't need to move back on that line in order to find the other carbons. Right, so let's just clear that and let's get the cursor selected and go to the next page. This is a branched compound. For example, we said Y, and we can see what is something called the main chain. So if I go there and there, that's 4 across, but the main chain has got 5 carbons. In this case, main chain has 5 carbons. Yeah? Righto. All clear? And there's 1, 2, 3, 4. So that's not the main chain because it's only got, actually this is very wrong of me. Let me just clear this. I've made a mistake. 1, 2, 3, 4, 5, 6. That's the main chain. So in this direction here, so down like that, that's carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So the main chain has got 6 carbons. Right, what do we see over here? That's what we call a branch. Okay, that's a branch. That's the main chain, that's 6 carbons. This is what we call a branch over here, and our branch has got 1 carbon. Now, you might as well learn it right now. When you got a branch that contains 1 carbon, we call that a methyl group, okay, which we'll speak about a little bit later.